Okay, so we have a couple things to do today. Okay. Alright, so we need to implement the B type instructions. Just make it a little bit louder. Let's see. Okay. All right. So we have me at 12 on the 31st bit. $25 to $30. Okay. Alright, then let's just start with the implementation. So this is for the S type, so now we need to implement one for the B type instructions. And I'll call it like branch, since that's for branch, so we're gonna get branch immediate and value. All right. I'm just gonna copy this for a second. All right, so let's call it in underscore 12. So we get this first value in, and that's gonna be the value shifted to the right 31 bits. So only taking 1 bit. Yeah, and then since it's only 1 bit, it just means index 1. And we can do the same with other variables, so me at 10 underscore 5. And this one will be shifted since we already did 1, right? So this one only needs. This one takes 7 bits, I'm pretty sure. No, it takes 6 bits. Yeah, 6 bits. So it takes 6 bits from 25 to 30. So it's gonna be shifted to 25, right? And it will, since it's taking 6 bits, that should be 3F in hex. So 3F. And I'm just gonna move this, bro. I feel like it's not getting it that long. Let's do 10.5. Or 10.5. That's fine. Okay. Hopefully it's better now. Does seem kind of loud though. Does seem kind of loud. A little bit too loud. We'll do just 10. Okay. Now we can continue. Alright, it's 3F. It's 3F, and now we need to do the other immediate values. Okay, the next one is down here instead. Which is the immediate for risc-v. Sorry, will be shifted. So it's 7, so just 7 bits. It only occupies 1 bit, so it's gonna be shifted. No, is it gonna be shifted 6 or no? It'd be 0 to 6. So to see, I'd be shifted 7, and it would take up 1 bit, so it would be 0x1 as before. Now we need one more immediate value, which will be, oh wait, no, wait, no, this is the implementation for the, I was looking at the wrong one. It's for this one, my bad. I'll just, okay, I copied it anyways. This one is from, oh, and this doesn't take 1 bit, this takes, no, it does take 1 bit. This, okay, this is from 8 to 11, so that's 4 bits. So it would be 8. I said 8. My bad, but what am I doing? Okay. Value shifted 8. And whatever that amount is, for now, I'll just write down to get this in first. Underscore, what is it? 11. And set that to this that we had before. And this will be, and since it's 8 and 10, 11, it's a 4 value, so it's gonna be F. That makes sense. So 0x So that should be the logic for that. Now we need to actually get it into one immediate. So it covers that. Or do we not need to do that? Hold up. Let's try and decipher the bits here. I think I'll put it in Paint so I can actually write and actually draw what I need to. Because I need to actually decipher properly. So well, I kind of already deciphered it here. So I guess we don't need that for now. If I need to, I'll come back to this. But yeah, I think we have it. Let me just look at this. So 4 bits, 1 bit, 6 bits here, and then 1. Okay. Alright, so I need to shift a certain amount over. So 6, 10, 11. So I need to shift it 11 bits. So the actual immediate value will be immediate underscore 12, and 11 shifted 11, right? Because we had 6 here for 10, so we're shifting 11 to make room for shifting left 11 to make room for these other 3 instructions. And in that case, we need that, or wait, so we're shifting 11, but we need to get the other values in. Is there any way to get this Yeah, I think we can. Okay. So it would have to be like, hopefully this is the right logic. If it's not, we'll ask Claude and see what's going on. But it should be that, and then we're shifting. Since this is 11, so this one needs to only shift 10. This one only needs to shift 10 for these 6. Then we do an OR statement, not an OR statement, and we have to do the next immediate shifted by 4, I believe. Should be 4, and this takes up 6. Or would it be 5? Wait. Okay, then this takes up to 5 to 1, and then 5 for 3, 2, 5, 2, 1. Okay, and then yeah, that's 5, and then this will take not that, and this will take up the last bit, which will just be that bit, that value in because that will stay on the first bit. So I think that's the right logic. I'll have to put it into Claude and see. Okay, so we have that, right? And then we also need the same logic here, because now this is all the bits shifted down, so we need to also take this back to do the sign extension and then return it. So that should be the immediate 4B type instructions, I think. I hope this is right logic. I hope so. We can test it though. Or first let's ask Claude before we add right test. Just to see if we've got pretty close or if we actually got it. I'm pretty sure this should be, like, if I'm not doing anything wrong, so let's see. Let's see. Wait. Oh, is it because of the mismatch with bits? Wait, so we have 1 bit here, 6 or 7, so we have 7 bits in total with this. 4, no, that's 12, right? So what's the mismatch? Wait. Oh, wait, that's why. Because this is the opcode. Yeah, I knew I should have, like, done a breakdown. Hold up, let's actually do the breakdown here. It'd probably be better to do that, so I can actually get it right. So, this is the opcode. Right? That is the opcode. Okay, so Func3 is 1 0 0, so the immediate for 1 is 0 1 1 0, right? 0 1 1 0, so this will be that immediate for 4. Now 1 0 0. Okay, 1 2. Okay, I think I see something here. It's like this. These are the 6 for that. What is that? 0 1 0. Wait, no, that would be wrong. So what exactly? Hold up. Okay, let's take it one step at a time here. All right, so that is the opcode right there. Right. So func3 for a BAQ 0 0 0. So I'm guessing this would be func3. I mean, now is where we get to this part. So I think it's like this. Okay, so it's 1 2 3 4 5 6. These 6 here. 1 2 3 4 5. This is gonna be the RS1 and the RS2. No, that's RS2. The RS1 is that one. RS1 would be that, and then this would be the. I think so. I'm not actually sure. Wait, so. Let me just finish writing it out here. Wait, no, but the instructions like that, so why is it wrong? Why is that considered wrong? How do you reselect one? Okay, so hold on. Or assume it's 24 to 20. 1, 2, 3, 4, 5, 6. So it'll be 0, 0, 0, 1, 0. First 1, from 3. So from 3 was 0, 0, 0, as we saw, right? Function for big key is 0, 0, 0. That's correct. That matches that. So 0, 0, 0. That's right. Zero, 1, 0, 0. And that's going to be the immediate for that. And then in this case, it's going to be the immediate 11. So we got what? We got down to here. 0, 0, 0. And we got 0, 0. And then 0. 1, 1, 0, 0, 0, 1, which is right. So it's going to be that. So that should be right. So why would this shift not be right? I'm kind of confused. Try and write it out. Okay, wait, so if we shift that by 11, so if we have that one bit and we shift it 11, so if it's at the starting point and we shift 11, so 1, 2, 3, 4, 5, 6, 7, 11. That should make enough room, right? So why is that shift not right? I'm shifting this by 10 to immediate. This by 5, right? It should be right. And that occupies the first bit. Why is that logic not right? Let's check. needs to land at bit position 12 and the final value shifted by 11. Those are different positions. Wait. Oh, I see. Okay, that makes sense. Wait. Okay. So when you see a shift always starts by 1, I just got it 1 off. So that'll be 6.5. Wait, maybe no. I think that's right now. Unless I'm just like really being dumb here, bro. It's just 11, so this takes up 6 bits, this takes up 4 bits, this is 1 bit. Interesting. Oh, okay, I see. Wait, I see. Since it's taking up 6, okay, I see. So it'd be occupying the lower. At first, it'd be occupying the lower 6 bits. So we need to shift by. Yeah. So we shift this by 5, and this would be. Since it's taking that, this takes up 4 bits, so we need to shift it. We just need to shift it 1 for this, I'm pretty sure. Right, now we have to fix the sign extension, this piece of logic. So okay. All right. Wait, no, we don't. Wait. pretty sure occupies the 11th, but I thought it's the bottom bit though. I thought that's what it showed in here, but I guess not. It's quite confusing for this one, I'm not gonna lie. For the beat type. Let me just check this in hex real quick. No, I need to check it in binary. So this number. Okay, so does it pad 1 0? Is that why it's like acting like that? Okay, so we just need to add one extra 0 to that number. So that'd be hex 1000. So I'm not gonna lie, they made the beat type so confusing, bro. Because every other immediate is 12 bits, this one's 13, so. Immediate 0 is implicit. And which one would be immediate 0? Oh, okay. So we have our 4 immediates, and there's another one that's implicit that's not actually like. That's why. Okay, that makes sense. Wait. Okay. fill everything above bit. So let me just check this in hex and see what it's binary, and you have to add an extra one. So that number in binary. Let's set it back. And wait. Okay. That's true. Alright, so we don't need to actually add one, we just need to change this to 0. I believe. Hopefully. There's too many issues in 11's at the wrong position, yeah. So it'd be this value instead of this. And since this is a 12th bit, the 11th bit should be that immediate, right? I think. So I think the logic should work out now. Took a little while, but we got there, hopefully. Let's see. Alright, okay, so we finally got the B type right. Alright, that makes sense. I just didn't know that this bit would move to the 11th position. And now there's an implicit immediate too. Interesting. Okay, now we can actually like implement them. We can actually implement them into our function now. So first, let me add this to the header file. Put it right over this, the store intermediate. Alright, so it's added to the header file. Now we need to actually implement the logic here for the opcodes. So let's take a look here. So for a branch if equal, opcode is 11000011. Let's get this in hex, which is 63. So opcode for B type instructions are going to always be 0x63. And now we just need to compute our different func3s for each one. So func3, I guess is 0x0. We should probably initialize our new type too in our on const variables type B. Okay, so that's straight. Everything looks good. So this will be type B. And what values does that take? So it takes immediate value, and it also has an rs2, right? I'm pretty sure it has an rs2, right? Yeah. So it has an rs2 and an rs1. Okay, so that's good. That's good so far. So this will be kept, and then the name is BEQ. Branch if equal. Then we can do the same for the other instructions in eType. Do the same exact thing. Let's see. We have 5 more instructions. Okay. Branch if not equal, func3 is 0x1 instead. And BNE, not BNE, BNE. And next, func3 is 4, 0x4. And what was that? BLT, branch if less than, okay. That's right. This one is 5. Oh, we need to change the name for that, my bad. Change the name for that. Unsigned. Branch if less than unsigned. Oh, I also forgot we need to change the function that we're calling for each one of these. It's not stored in its get branch, right? Get branch, yeah, we need to change that for each one. Just copy. Good now. All right, yeah. So the transition from S to B type instructions is there, and this one is going to be the next one after that. Branch of greater than or equal to, so BGE, and it has output 5. Oh, that's output 6, not 5. That's 6. This one is 5. For func3 not opcode. BGE. Last one is branch of greater or equal unsigned BGU. Type, and this one is different. It's 7. 7. Should be right. And what happened here? Oh, extra parenthesis. Okay, so that should be right. Now we can implement in main here. So if our instruction.type is equal to type B type, okay, so type B. Okay, let's see how the instructions. So instruction main. Alright, let me see how like the instruction is written again. So we have BQ. So for each one we have an rs1, so we need to get the rs1 value, which will be inst.rs1. rs1. Next, rs2. And And we need our final one, which is the label, which is where we're jumping to. So we need to set so I think we need to set a new like variable here. So how would our label be for this? So where the branch is trying to go to. Wait. I mean, it usually goes to. Doesn't it usually just exit if it just jumps to exit, I'm pretty sure, right? No, that's not. No, that's not okay. PC plus offset. So the program counter plus the offset, which is usually 4 to jump. Do I have anything set up? Oh, shift amount? No, it can't be shift amount, no. Right? Yeah, I don't have. Oh, you can just print the media value? Okay, I didn't know you could do that. Okay, that makes sense, okay. I didn't know you could actually just print the media value itself. I thought you had to get the actual thing you're jumping to. Okay, so that resolves that, so it's just that resolves that, so okay. Now we need to test if it works. Give me some example bit strings for B type. Okay, so after running that, we should be getting that. So let's see. Invalid. So we must have messed it up. Oh wait, no, we copied the wrong thing. My bad. My bad. Let's redo this. Rerun that. Okay, yeah, it works. So branch v equal x1, x2, and then the offset is 8. And let's test the other two cases. BNE x5, x6, 16, that works. That's also right. And then the last one. ELT x3, x4, -4. So our sign extension works for negative values as well. Okay, so that's perfect for that. Alright then. Alright, that's actually perfect. Alright, so we just finished doing all the B-type instructions. So far, we have R-type. We have all the arithmetic instructions done, so all of these instructions, we have almost all the memory instructions. I need to just do the I-type, which shouldn't take that long. They're the same as these ones, pretty much. Just the opcode is different, but the logic's the same. Then J-type. I don't know how different J-type is. Let's take a look, though. And then we also have U-type. I have not seen. I don't understand U-type yet. I haven't gotten to that yet in the book. But once I get there, I'll get there. But let's try and see what a J-type would look like. So now let's get the breakdown of bits for J-type and let's construct the thing for that. Oh, it's even more scrambled than B-type. Okay, so it's gonna be even more complicated. Hopefully not, since we already went through that. Hopefully it's not. Hopefully, okay. Okay, so bit 31 is immediate. Let's just use our function that we had for branch and just try and build it. So, okay, so that's 1 bit. Okay, that takes 11 bits. From 21, no, not 11, my bad, 10 bits from 21 to 30. So let me write this down. All right, so it's 1 bit, 10 bits right there, 1 bit here, this, and then 8 bits here. So in total, this immediate takes 20 bits. Okay. Right, so that's 20 bits, and then the rest, destination register takes 5 bits, and this takes 7 bits, which adds up to our 32 that we need, so that should be... We get 21 bits, okay, wait, hold on. Oh, there's another implicit 0. Okay. Damn it, bro. Why is there always implicit 0? 21 bits total. So it's similar, it's also 13 bits. Okay. Alright, let's deconstruct this one. Try and figure out what is actually going on. First, I kind of want to understand what that implicit zero is. Here's the instructions. Instructions are always 4 byte aligned. Okay, multiple 4. 0, 0. There's no point in encoding information in instructions. Okay. 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 Got it. Okay. So we always need to include it, but it's just not there. It's just implied. Okay. That makes it much more better for me to actually understand what's going on there, to decode it better. Okay, so let's actually decode this. So obviously our opcode at the end, we'll just get that out of the way. Which is that value. So that's our opcode. Immediate 20 is going to be. Wait, let me just copy this into here so I have it here and I can look at the chart at the same time. Okay, so immediate 20. That's just our first 0 up there. Immediate 10. That takes up 11 bits as we said. So it'll take up this, believe so. Okay, now next moving on from here, which will be the 1 bit, so just that 0. That 0 for that, and then the next one is 7 bits, so no, 8 bits. So these 8 bits. Oh shit, no. I forgot to press shift. My bad. We'll just edit it. I know I'm missing those. Which this one would take up at 0. The last one. think it's that. How much bits? It takes 5 bits, right? So it should be that. I believe. RD is that. Okay, let's see. Does that match? Yeah, it matches. I think that's right. Let's see. Oh, did I write 11? That's my bad, bro. That should just be 10. Okay. So the bits are all in place. Okay, now we can actually get like the. Now we can actually get this going. So get job immediate. Take an unsigned info. Alright, let's actually write it now. So it's the 31st bit, right? So it's also going to be shifted 31 and take hex of 1. There we go. Next, we have the 10 to 1. Oh wait, that's im_20 nodes. Next, we have im10_1. Which we have a value of since it's taking 10 bits, right? So okay. I think it should be a bit 22, right? And what is the hex for that? 3FF. So 0x 3FF. What's the next value? That takes 1 bit, so pretty much 11. We'll take the value of and 0x1. Then we have the final immediate here, which takes 8 bits. Which will right shift the value of Pretty sure. And what is the hex for that? Okay. 0xff. Alright, that should be good. Now we need to get the logic for the overall immediate no. Okay. So same case scenario, our immediate shifting by. Okay. Since we have 21 bits total, right? Okay, so we're gonna shift by 21. Or no, we're shifting by 20. We're gonna shift by 20. My bad, it's not 12. Sorry. This one would be left shifted by how much? Let me just set up all these. I think it might be easier to look at it from that way. Okay, let me write this part down. So okay, so we just need to shift that by 1 because we're taking those bits 10 down to 1. Okay, same for that. Now for this one. Okay, so it's that's at the first position. How many bits is that one take? That takes 1 bit. So finish that one, and we need to get it to the. Okay, we need to get to the 11th position, so we're shifting it by 11. And for the case of this one, oh wait, no, we got it backwards. Wait. These two are swapped. These two are swapped, the second and fourth. This one should be here. And this one should be right here. Yeah, okay, now it's right. So this one takes up 8 bits. So it's gonna be 0, 7, so we need to shift it to the 19th bit. We need the leftmost bit to go to bit 19. So we're shifting by 12. Pretty sure. I think that's right. And then we need to do the sign extension. Okay. So what is this value next? What is this value in binary again? Let me see. Hex to binary. I see, okay. And I'm guessing that's 11 zeros? 12 zeros. Oh yeah, 12 zeros, okay. this case, since we have 20, we need 20. Okay, we need 20 zeros. Let me try doing that. I think that should be the right hex number for that. And then we need to do that, or okay, so the sign bit's gonna be on the 21st bit. Let me get this value for 1 second. Okay, so that's like that. Right. So we just need to make these all zeros, which are some 8 ones, so we need to make the rest of these zeros. Hopefully I got that right. Oh shoot, wait, no, bro, our cursor's up there, my bad. Okay. That's what I think it's gonna be. Now we just need to double check with Claude and make sure I actually did the logic right and didn't screw up any parts of it. Then after this, I think we'll call it a day and then continue off tomorrow. Oh, not bad. They should all be ors, not left shift. Those aren't right? No way. Okay. Interesting. Alright, bro. Let's see. I see, okay. So we just interpreted it wrong. So let's try to get that correct again. So let's a bits 21 to 30. This one should be 12. Okay. So you're right, the immediate for this, it's not shifted by 11. It'll be shifted by 20. And for the case of this one, it's 8 bits there, that, and it's okay. So that should be 11, I think. No, it's gonna be 12. And that's gonna be shifted by 21. I think so. We changed the oh, right, okay. The shifts are wrong. The extraction shifts. That's weird. Claude's telling me like different things, bro. First he said to do it this way, and then he's now saying a different way. I think Claude's getting confused, bro. I had him right. Okay. Alright, buddy. Alright. That takes 1 bit, that takes 10. Shift by 9. Just by 1. Let me just write this down on paper so I actually like know that I did it right. So we have, okay. That's that. Implicit bit, okay, now we have bits 1 through that, so. Okay, so that's 0, and okay, now this is bits 10 down to 1. Okay, so I did that one right. It's just shift by 1. Okay, now this is shift by 11, right? So if we start at 0, we shift by. Okay, yeah, that's right. Minus 10. Okay, we shift this. This should be the final. So, what idea? Alright. Should be the final. Let's hope that we change everything properly. Oh, yeah, the return value, that's the best thing, yeah. Yeah, okay. Now, return in. Alright. That's where Claude was kind of confusing me halfway through, bro. I'm not gonna lie, I kept saying like one thing or the other. Like different things at the same time. Alright. Alright, at least we finally got that down for that. And just implement the actual logic, and then it shouldn't take that long to implement the logic for the else if, because it's only one J instruction anyway, so okay. Okay, let's just go. Okay, So what is it for our J instruction? J type. Opcode is 11 this value. In hex that would be 6F. 6F, and then func3 is, we don't have one, so we don't need to implement that. Oh, I forgot it, we don't have one. So it's just that. Right, and then implement it here. So it's JL, dump the link, type J, which we need to include in our const. Okay, that's good. And we don't need RS2, I'm pretty sure, because it's just the destination register. So for this, it's just a destination register and the label where we jump to. And let that value in 2. So it's just that. And then it should be child. Okay. That should be right. Then add it into main. Or we already have one from earlier, I'm pretty sure, up here somewhere. Well, I kind of want the name of it too. Okay, that's not what I meant, but... Alright, that's fine. That's fine. No, we don't need the X anymore. It's just gonna be... It's just gonna be that, I think. So we have the name, so we have the gel instruction. Let's go back here. So gel, the RD, and then the label, which I think, yeah, that should be. Let's just test it out. Everything is good, right? Yeah, okay, so it does work. Shall in the first destination register, and then R offset of 8. Okay, looks like we got the J type, which means that we got B type and J type. Alright, that's good. Alright, I think that's gonna be it for today. Did quite a lot of logic today, but I am starting to get like slowly better. I'm not gonna lie, Claude was kind of confusing me. Hopefully like Claude actually gave me the right stuff, so I'll check with some other AI too to make sure Claude didn't actually screw me over here with this stuff, because it kept telling me different things. So yeah, I think that's good, and we'll continue off tomorrow, guys. See ya.